Good afternoon and welcome to NASA's Wallops Flight Facility in Wallops, Virginia. I am NASA Public Affairs Officer Trent Parado, and this is the post-launch briefing for the Orbital 1 mission. For those of you who are lucky enough to be here at Wallops, or for those of you who watched from home on NASA TV, you saw a beautiful launch of the Orbital 1 mission as it began its International Space Station, the route to the International Space Station at 1:07 p.m. today from right here at Wallops Island, Virginia. You can follow the mission as Cygnus is on orbit and begins its route to the International Space Station at www.nasa.gov/station. Here to talk about today's launch and a bit of what comes next, we have a number of distinguished guests. Each will provide some brief remarks, and then we'll go to questions and answers. If you have questions for our panelists, you can reach out to us online on Twitter or Google Plus using the hashtag AskNASA. Let me introduce our speakers. To my left is Robert Lightfoot, NASA Associate Administrator. Next, we have Frank Culbertson, Executive Vice President of Orbital Sciences. And we have Bill Rebell, Director of NASA's Wallops Flight Facility. And with that, we'll begin with Robert.
Okay, thanks, Trent. Good to see everybody here. Another very successful day at the Wallops Flight Facility. We're really excited about getting this mission off to, in my opinion, a tremendous start. So congratulations, Frank, to you and your team, and Bill, to the team here at Wallops for getting us started on this next mission. You know, this wasn't without some challenges. I think while they had some challenges during the count today, as we always do, if you back up, these guys were ready to fly back in December, and we had the cooling loop problem on the station, and the team in Houston and the team on orbit went out and took care of that problem for us. Then we had, I guess I would say, some of the coldest weather we've had in decades that managed to get us a day, and then what else but a solar flare coming our way. But I think the team persevered through that and really hit a huge milestone for us from an agency perspective here today with this launch. And the berthing on Sunday of the Cygnus spacecraft is going to be really an important event for us, because in so doing and in completing this mission, this will give us two providers to the International Space Station to provide us the cargo and supplies that we need to do all the research and the science and the technology that we want to use this amazing laboratory for. And coming on the heels of the announcement by the administration yesterday that we're talking about, we're going to start working to extend the International Space Station to 2024. It's just great news for us to actually take full advantage of the just amazing orbiting platform we have up there, to get us ready as an agency to take those next steps beyond the Earth orbit to the destinations we want to take people to. So a key enabler to that strategy is having commercial partners that can provide us that cargo, and today is a big step in that. So with that, I just want to congratulate the team here at Wallops and congratulate the Orbital team for doing that, and it's just a really exciting day for the agency and for the International Space Station as we move forward. With that, I'll turn it over to the people that did the real work here. Frank, you go ahead and start.
Thank you very much, Robert. It is a real pleasure to be here. It's especially exciting to be at a post-launch press conference. Mm-hmm. That's always good when you plan on doing that on this day. It was a challenging day, as Robert said, but this is what we do. The space flight is hard, and you have to work the issues as they come your way. And you've got to stay flexible. You've got to be persistent, and you've got to pay attention to detail, no matter what kind of things are coming at you from the sun or from DFOs, which are not aliens, I think, but distance-focused overpressure problems, mm-hmm. or at least analysis. But in the end, I want to thank the Wallops range officers, the range safety officers, the FAA, everybody who worked on this so hard, including the people who were standing out in the cold deploying the balloons on a frequent basis, so we could get analysis right down to the last second. And it was pretty much the last second. But it worked out, and we were able to get a green and proceed with the launch. I think we have some video that we can roll whenever it's ready to go. I'll try to talk over it a little bit and tell you what was going on as we launched, and then tell you a little bit about what's coming up in the next couple of days. The countdown went very smoothly. Once we got into the last 15 minutes, the team was focused and ready to go. All the instrumentation looked good, and as we lifted off, the Antares was right on its trajectory, accelerating as we expected. And as you heard, everything happened pretty much on time. It accelerates for almost 4 minutes under the first stage with the two AJ-26 rockets. And we want to thank our Aerojet partners for all the work they did to make sure those were ready. And our Ukrainian partners from Yuzhnoye and Yuzhmash who built the first stage. And it worked as planned. We heard it in the Launch Control Center. I heard that y'all had a great sound show, really, as you were out at the visitors viewing site. When the wind is out of the east, you get all the acoustics, and it really brings it home what's going on. There's a lot of energy in these rockets. And that's one of the challenging things of spaceflight is you are managing a lot of energy that's being transmitted very fast from potential to kinetic energy, and it's all got to go right, and it's got to happen at the right times, and you've got to do it over about an 8 to 10 minute period in order to get into orbit. You've got to accelerate to almost 18,000 miles an hour very quickly, and you burn a lot of fuel during that time, and everything has to go right. So everybody's paying very close attention at this time. Leading up to the launch, we did have some challenges. A lot of it was analytical in terms of understanding what was happening with the solar flare, dealing with the low temperatures, which were, you can keep it rolling if we have more. Dealing with the low temperatures was a challenge because that's not something we expected on the eastern shore. But we could deal with it, and we did, and the team worked together to keep things that needed to be warmed, and things that needed to be inspected. And we were ready to go today. And in fact, we were almost ready to go yesterday, but the solar flare kept us on the ground. Once the first stage finishes its job, we are almost outside the atmosphere, over 100 kilometers, and we separate the first and second stage, separate the inner stage, and then we ignite the second stage. The second stage on this one is a Castor 30B, which is an upgraded version of the Castor 30 we flew on the first two flights, built by ATK, and we appreciate the hard work they put into that. It again performed just as we expected, right on the money for second stage, and we ended up in orbit where we expected to be. Payload separation occurs about 2 minutes after we finish the second stage, and that's when we all relax. You see the launch control team paying attention to their consoles and going through their instrumentation, watching what's happening. A lot of people get excited when the first stage finishes and think, yeah, half the work's done. But you got to remember, okay, now we got to do the second stage, and then after the second stage, you still got to get rid of that rocket and put that payload in orbit where it's supposed to be, so that you can actually do what you intended to do, which is deliver cargo to the International Space Station. And we are right on the money, if not a little better. We're in a 218 by 280 kilometer orbit, which is slightly higher than what we needed in order to be on target, well above what we needed in order to do extra maneuvers in order to stay in orbit. So we're in good shape. Frank DeMauro, who's sitting back there, and his team have taken control of the spacecraft. The solar arrays are deployed, the power is up and working, the propulsion system is working, and the spacecraft is under control. And we'll do our first burn for continuing or beginning really the phasing with the International Space Station, so we can catch up with it and rendezvous with it in a couple of days. That burn will occur at about I think 6:23 tonight, and then we'll have a few more burns as we go over the next couple of days while we continue closing in on the station. The actual rendezvous will begin at about 3 a.m. Sunday morning, the 12th of January. It'll take about 3 hours for us to get close to the station, and then the actual capture will occur at about 6 a.m. Sunday morning. And that's another exciting time for us as you get close to the station and watch your spacecraft approach up the R-bar, getting closer and closer, bigger and bigger, and you think, I hope it has brakes. And and the station crew knows what they're doing. And they do, and we do have brakes. Last time we stopped at about 10 meters, and they did a great job of grappling. We expect it to be the same this time. The crew will then berth us to the station, and then they will wait until the following day to actually open the hatch and get their Christmas presents out. But they will, in fact, open the hatch and find a nice picture of C. Gordon Fullerton on the back bulkhead. This is the SS Gordon Fullerton, named in honor of one of my colleagues and our friends at Orbital, Gordon Fullerton, who was an astronaut and also a B-52 pilot at Dryden Space Flight Center, who dropped our first commercial rocket, the Pegasus, from the underside of the B-52. So Orbital has a long and productive relationship with Gordon. He passed away about a year ago, and so we miss him, but we wanted to honor his memory by naming this spacecraft after him. We've got about 1,460 kilograms of payload cargo on board this pressurized cargo module. About 400, almost 500 kilograms of that is what we loaded late. Much of it was science payload, and much of it was student science, student experiments. So the ISS is doing its job to continue to ensure that the next generation is interested in spaceflight, has the ability to do research in space to get them interested, so that in about 15 or 20 years you'll have somebody a lot better looking and smarter than us up here to talk about what's going on in space. And we are proud to be a part of that and to assist the space station in continuing the research that's been going on for over 10 years and continue to further the boundaries of human knowledge and soon the boundaries of human exploration, because the station, if not actually, will virtually be our stepping stone to the rest of the solar system, and we're very proud to be a part of that. I look forward to your questions. I'll be happy to answer any of them, and now I'm going to turn it over to our Center Director here, Mr. Bill Robel.
Thanks, Frank. Thanks a lot. Yeah, so great way to start out the new year, certainly, and we're looking forward to doing this a couple more times this year, I think.
Right.
And then, as Robert pointed out, with an extension of 4 years, maybe a number of years down the road after that. So that's all very good news. Obviously, we're all smiles here, a lot of happy engineers kind of across the area. I just have to echo the congratulations to the teams. They really worked hard at pulling this off, obviously through some pretty tough weather, and not all of it terrestrial based, right? So it was just a great effort across the board. A couple of other things to see that are going to be taking place here at Wallops in the coming months is that we were part of one of the teams that was selected for the Unmanned Aerial Systems Test Site designation by the FAA. So we're looking forward to the work that's going to come with that in the future. And we've got some other interesting things also coming up this year. But we're all smiles here as a result of the way things went here early this afternoon. Good show.
Thank you, gentlemen. All right, let's start with questions here in the audience. As a reminder, if you're watching from home and you'd like to ask our panel a question, you can do so using the hashtag AskNASA on Google Plus or Twitter, but we'll start right here at Wallops. We'll start with Ken, and then we'll go to Stephen. We can get a mic to Ken.
Hi, Ken Kramer of Universe Today. Congratulations on a great launch. It was really beautiful and a great way to start the new year, exactly. Mm-hmm. So my question is for Frank and maybe Bob. We did get an extension announced yesterday. So I'd like you to talk, what does this mean to you as an astronaut, getting an extension to the ISS, but also specifically in some detail, the point that Bill Gerstenmaier made yesterday. This lets the commercial providers and others plan for the long-term horizon. So how will this specifically help Orbital as a cargo carrier? What would you like to do? Thank you.
Well, to answer your first question, I think it's fantastic that the administration is committed to moving towards extending the station. I know they've got to work with the partners, and there's a lot to be done yet, but it's a move in the right direction. In my opinion, if I had my way, we'd fly it till 2050. Now, Congress would have to agree to that, I guess, but there's really no reason to stop operations on the space station until it completely is no longer usable. And I think it'll be usable for a long time because it's very well built, very well maintained, and NASA and their engineers understand it very well, and I think they're operating it superbly. The best thing about it is it's now a research center, and it is really starting to ramp up. It's not there yet. It's finished as a station and as a laboratory, but the research capability is just starting to move in the right direction. So extending it gives not only commercial companies, but researchers the idea that, yes, I can do long-term research on the station because it'll be there for another 10 years and I can get some significant data. And I think that's really important for them to understand, that it's going to be backed for that long. They won't get cut short in the middle of preparing an experiment or flying it. So I think that first of all, demonstrates the commitment of the government to continuing and to NASA, but also presents a lot of opportunities for a number of people. As far as what it means for us and other commercial companies is that, yes, it does allow us to plan long-term for what we might be able to do, providing a service for NASA in the future, and also gives us a chance to be innovative and maybe invest in some improvements on how we can do this to make it more cost-effective, more efficient, turnaround time quicker, go a lot more often, Robert, and get so good at it that they don't even feel like they have to compete for those next few extensions. We'll just keep going. That's our position, but we have to see what the government does. But it really does give us the chance to think long term and make sure that we can get some return on our investment, and that it actually does present a business opportunity that can expand not just to the station, but to other uses in space flight, such as exploration, asteroids, Mars, wherever we're going. And we hope it'll transfer into other civilian uses and in space. For maybe other stations will follow this one, and we'll be able to participate in that.
Stephen.
Did you want to add?
Yeah, the only thing I would add on, Ken, is that Frank said it right when he said the station is really our stepping stone. And if you use that analogy of stepping stones, the next stone, we need to use this stone to know what the next stone looks like, right? So we can get ready, whether that's research, whether it's what it does to the human body, the things we're learning today. You don't want to jump off that platform before you're ready. And so we're learning every day how to live and operate in space. And fortunately, we're close to home, and if something comes up, we can get home. The further we go, the more we need to know about how to operate in space, what kind of protection we need, what kind of research we need for the astronauts, but also what kind of systems do we need. And these guys are putting systems up there that allow us to just test more and more, get more time, because when we get further away, we can't get home as quick. And so those are the kind of things that we get to do. And with this extension, I can now make those investments as an agency, not just us, but our academic partners, our industry partners. Yeah, the launch market is part of this, as these guys have shown today, but it's also the researchers, the scientists, even universities now can do that. I mean, if you saw the excitement today of the kids and the students that were out at the viewing area where I was, for just being able to take a CubeSat, a 4-inch by 4-inch cube that they've worked on, and they just launched today. That's pretty cool. I mean, that is exactly what we need to be doing, and that's the people that are, as Frank said, are going to take our jobs. And as long as they know that's going to be there for a while, this gives them that chance to train and learn and do the research that we need to take people further. So that it is the stepping stone, and it's really important for us to have this extension.
I spoke to them yesterday. They were very excited.
Yeah.
I think we all envy them.
Yes, I think we do.
Stephen.
Thanks, Trent. Stephen Clark with Spaceflight Now. A couple of questions for Frank and Robert. First, for Frank, the ISS extension to 2024, and your current contract runs through the 2016 timeframe, I understand. A lot more flights potentially for Cygnus and Antares. So beyond 2016, as you get your cadence down, what sort of cost savings do you expect to be able to offer NASA from the $1.9 billion CRS contract? And also for Mr. Lightfoot, when do you plan to recompete or extend SpaceX Orbital new providers? How do you foresee that mechanism working, and when do you plan to do it? Thanks.
Well, if Robert answers first, I might be able to give you a better answer.
Well, and I think for us, part of the whole, we have an acquisition strategy we'll go through as an agency in terms of how we go purchase these services in the future. One of the key parts of that strategy is how long, right? And so we just got that yesterday. So we'll be folding that into our process for any extension that we do in terms of the service provider. So we're just now, I mean, this was part of our strategy, was to first know we're going to try to go to 2024, and then that'll fold into our acquisition strategy as we go forward. So we know we got till 16. We've got flights with Orbital and with SpaceX already on the books, and this will actually begin to shape our strategy as we go forward. We just haven't gotten that far yet.
Yeah, the variables are the same for both sides of the equation, whether you're the customer or the provider, and that's understanding what's available, how long you want to go, and then what is also possible in terms of reducing costs. I can't tell you in front of these guys what kind of numbers we might be thinking about, but we definitely will go to more of a production mode rather than a development mode on the spacecraft and the rocket, and we've already demonstrated that in the company with our commercial satellites that we provide for ComSats and for science use and other purposes, where we just turn them out of the factory with modifications as necessary for the customer. And we really can get very efficient with that if we can do the same design over and over. And that's what we would intend to do for the next phase of CRS services. we would like to see NASA tell us as quickly as possible what they want to do, because the sooner we know, the sooner we can get other vendors, other suppliers on contract and get our plans in place to give them the most cost-effective solution. But definitely this extension, I think, will help move things along.
Okay, Robert, and then we'll take one from social.
Hi, Robert Perlman with CollectSpace.com with a question for Frank. Looking at the more immediate future at the 2 flights for the later this year, can you give an update on where you are with the hardware for those flights, both Antares and Cygnus?
Sure. Our next flight is planned for early May. May 1st, I think, is the current planned date. The next one is in early October. We actually have virtually all the hardware for both of those flights, either here or in process. The long pole on the Antares is the engines, finishing the ATP acceptance testing at Stennis and getting the engines delivered here. We've got other cores on the way here, so we'll actually have, I think, 4 cores here in about 2 weeks, which will take us into next year. On the Antares side, we have the first. We've got the spacecraft completed through Orb 3, and Orb 4 and 5 are in work. And the PCMs have actually been completed up through about Orb 6. That's the pressurized cargo module, with the last 2 going through final assembly now. And then the subsystems are either on order or on dock. And so we're in very good shape in terms of availability of hardware.
We'll take a question from social. Okay.
Wonderful. Our first question from social media comes from Twitter user JupiterFix. Could Cygnus make a 4-orbit rendezvous profile and dock to the ISS in 6+ hours?
Mr. DeMauro? My program manager is sitting back there, and the challenge I've given the team is to get there in 1 day. So we're working on that. This really is just our first contract delivery flight, so we're being somewhat conservative. But actually, we're getting there in half the time we would have on the demo mission already. And if the phasing were right, we could probably do it in 1 day less. It really depends on where the station is when we launch, and how long it takes us to finish all of the orbital adjustments. But I really would like to get there in 1 day to support the science program and get the cargo on board as quickly as possible.
Let's do one more.
Wonderful. Our next question comes from Twitter user Greg Beat. Did the Castor 30B, the new second stage, perform as expected?
Yes, it did.
Let's go to the phone line. I understand we have a couple reporters there. We'll start with Tarek Malik from Space.com. If you have a question, Tarek. Let's try Dan Leone, Space News. Let's go back to Wallops. Any questions here?
They told us there's going to be a blackout with that solar flare.
Could be solar flare. Any further questions? Go ahead, Stephen, follow up.
Yeah, just a quick follow-up for maybe Frank. How long is this mission programmed to last? 30 to 45 days? What's the variable there?
30 to 45 days, and the variables really are on NASA's side of the equation. They've got another mission coming in February, SpaceX. They've also got a Russian EVA and a Russian Progress that are coming up, and so they have to work all this traffic model together. We will guarantee them at least 45 days up there if they want it. Right now, I think it's 40 days, Frank? So we have some flexibility there. I wanted to add one thing to a previous answer, if I could. What? Who's that?
That was you.
Oh. I know Trent hates it when I do this, but we were talking earlier about the extension and what that means, and we talked about the ability to get more science up there and to make more plans. I think another thing that we need to push really hard for with commercial cargo, commercial crew transportation, and the other capabilities that are coming in the country is to fly more people to the space station on a more frequent basis. Right now we're flying people for about 6 months at a time, crews of 3, rotating in overlapping fashion, and a cruise of 6 in overlapping fashion. We may eventually get to 7, but the more people we fly, the more interest we'll get in the country. And I think there's a place for people who need to be up there for 6 to 12 months for a variety of reasons. There's probably a place for people who could go up for a month, finish their experiment, and come home. Now, I know all you need is a little more money for transportation systems, Robert, but think about it in terms of how many people could then come back and tell people about what they've done. and push the program and help move it forward, as well as how much experience could we continue to develop in this country in space flight. How many hours, how many days could you spend in space, and then how ready those people will be to do the long missions for exploration to the moon and Mars and beyond. So I really think that having a longer commitment by the station and an encouraging industry to come up with more innovation on how to efficiently transport cargo and crew up there will help NASA then maybe transition to a higher traffic model for the crews themselves. It's just my opinion.
Let's go back to the phone line, see if we can get Tarek Malik. Go ahead, Tarek, if you can hear me. All right, let's do a follow-up with Ken here in the audience, and then we'll go back to social.
Hi, follow-up for Frank. Ken Kramer first today. Talk a little bit about, you've got the larger Cygnus, extended Cygnus cargo module. What will that allow you to do? And also looking in the long term, talk about the possibilities to leave a Cygnus up there. Again, in relation to the fact that ISS is going to be there longer now, so this may give you more incentive to develop a long-duration Cygnus.
Oh, we're happy to do that. Yes, the extended Cygnus will fly, or enhanced Cygnus as we call it, will fly on Orb 4, which will be early 2015. It'll be a meter longer. It'll carry about 600 or 700 kilograms more of cargo than the current one, which of course gives NASA more flexibility. And we think it'll also benefit the station greatly by being able to get more cargo up there. And now we don't want to have the downside of saying, well, you carry more so you fly less often. We just want them to do more up there, so they'll need to use it. But it also allows us to take heavier and denser cargo up there, including water and batteries and things like that if needed. As far as staying on orbit longer, we've had discussions with NASA and other people actually about that with Cygnus. The spacecraft itself is based on the legacy of our commercial satellites that are designed sometimes for as much as 15 years. And so we've got really robust components in the spacecraft with a lot of capability for maneuvering and rendezvous, as you've seen. And so I think it could be used to support exploration. It could be used to support long-duration missions elsewhere. It could also be used to test systems on the station if NASA would like to do that. They could attach a Cygnus, unload the cargo, and then activate a life support system, for example, for testing for a trip to Mars or wherever they'd like to go. They could actually lock a crew in there for 12 months and see how they do, and simulate a Mars mission. I'd do it.
Yeah, but I think to your question, the extension allows us to start having those kind of discussions in a very serious way, right? Because there's a lot of those. There's a lot of those kind of examples, and as long as they're all aligned with where we're heading from a perspective, like Frank said, where we're heading to take people further into space, those are the kind of things, the kind of discussions we'll be able to have now, with a much longer term view of where we want to go. So that's what's pretty exciting about it.
Let's take two more, and we'll let you guys get back to spaceflight. We'll take one from social and do a follow-up with Robert. Go ahead, Jason.
Wonderful. This question comes from Twitter user Dean Ripley. Does Orbital Sciences plan on the development of a human-rated Cygnus module, assuming the continued success of CRS?
Right now, we're not working on human rating the Cygnus itself. It has a certain amount of human rating in order to be able to fly to the space station. But in terms of being able to launch people in it or to return people to Earth, it's not currently in our plans. We could make modifications, but that's a ways away.
Robert.
Actually, since the phone lines weren't working via social media, Tarek Malik from space.com. A question for Frank. How long is Cygnus going to stay at the station? Do you have a target undocking day?
Well, about 40 days is the current plan. We could stay 45, and if NASA needed us to, we could probably figure out a way to stay longer, but currently 45 is what we're contracted for on this mission.
Inventive, like it. Okay, that's going to do it. So as Frank said, we have we're looking ahead to Rendezvous on Sunday, January 12th. NASA TV coverage of that will begin at 5 a.m. for a 6:02 grapple. NASA TV coverage will continue at 7 a.m. for the installation by the Expedition 38 crew as they berth Cygnus. So on behalf of everyone here at Wallops, I'm Trent Parado. Thank you so much. Please help me thank our panelists for joining us today. Go Cygnus. Thank you.